Alright, so I'm trying a new way of going about doing this, and hopefully this works. So, my wife came up with this idea. She is super smart. Um, so we're going to do something here. And the idea is some sort of kind of accumulation problems that could pop up. Again, expect to see free response questions. And just like I posted, we're looking at May 12th, so a week after when we were normally expecting to see the AP exam. Now we got May 12th coming up. So, yeah, so you have this right here. We can try this out. Obviously, on your own first would be a good idea. And then we'll go from there. Now, with this, we'd want to, got a few different things going on here, so I got a line of Spartan File at 10 a.m. on Tuesday. I was just over there because I had to go to Petco to get some flightless fruit flies we have a bunch of mantids that we needed to feed. So anyway, I was right there and I needed to get some milk. So since the line, at the time, the staff was only allowing one person in every 5 minutes because they had too many people, the line was too long, and they couldn't keep people 6 feet apart. So I figured I would look at the calculus of the situation, and people joined the line at a rate of that, which is 5.991 e to the power of 2.996 t. So that t is up in the power, measured in customers per hour. I was the second person in line. So, yeah. So now we're here with this, and I said, okay, we want to find and interpret 1/2 the integral from 0 to 2 of r of t dt. And so with this, hold on a second, I forgot to grab my calculator. But yeah, so yeah, the little one, he likes to grab this, so that's really exciting when he wants to play with it. But so anyways, 1/2, 0.5 times the integral of our function, which was 5.991 e to the 2.996 x comma 0 comma 2. All right, so we have that there. Actually, at the time, I was only there for about an hour, so I just kind of extrapolated this. But all right, so with this, a few things we should be taking a look at. Whenever you see a fraction, something should say average value. Okay, so you see that, especially if it's the difference right there between those two, from 2 minus 0 to 2, so that's average value we're talking about. And so it's the average, and in this case it's the average value, the thing what r of t is the average value of r of t over a to b, or 0 to 2, in this case on that interval. Okay, so we got that going on, and so this comes out to be 399.148 is what that was. And this will be, since this is the average value of r is measured in customers per hour, this will be customers per hour. And so, and this was how many people joined. This is the, so people joined at this rate, so this is the average value of that, which means that this then is the average rate people or customers joined the line at Smart and Final. And then we got to address this part, the 0 to 2. So that's going to be between 0 was t equals 0 is 10 a.m., so 10 a.m. and noon is what's going on there. So that's the idea. Okay. I kind of expect to see some sort of average value thing. This doesn't go away, and it's a good thing to really find out if people understand what's going on. So I kind of am leaning towards that sort of idea. All right, so now we want to write an integral expression that would give the number of customers in line at 1 p.m. So t equals 3. So so with this, so the number or the total will equal the starting amount or the initial plus the gain minus the loss. Because so there's same amount of people in line at the beginning. We're gaining people the entire time, but we're always losing people because people were going into the store. So our total then would then be the starting amount. So I got in line at t equals 0, and I was the second person in line. So the starting amount would be 2, plus our gain, which would be the integral from 0 to 3 of r of t dt, because this is how much, how fast they're joining the line, minus the loss. So the loss then would be the going from there was one person every 5 minutes, and now we're talking about hours, so 3 hours. So one person per 5 minutes means that's how many people over that course of that time. And so be careful because of but that's going to be 12 people per hour. So that's going to be 12 times 3, and there we go. And so this is just a kind of a real basic idea. All right. So now talked with someone at Stater Brothers who said the number of customers in line there could be modeled as this: s of x equals 100 plus 150 inverse tangent of the quantity x over 4. X hours after the store opens at 11 a.m. So in the other one, t was for it's just something, I don't know really how they're going to mess with you, but they're going to mess with you somehow. So this is the idea, and I'm thinking, hey, let's try to think of all the funky ways we could do it. But you're going to want to compare things, to see which one's greater, and then explain why. And so what we want to do is we want to look at different stuff. Now, we have two different things. So at 11 a.m. So 11 a.m., remember, t equals 0 at 10 a.m., so 11 a.m. means t equals 1. But 11 a.m. in this case means x equals 4. And so we got two different things, t equals 1 and x equals 4. And we want to know which line is growing faster. So remember, when it comes to Smart, we're going to be comparing Smart and Final with Staters. So Smart and Final, so which line grows faster? Okay, so both of them are going to be growing, but so with this, we're at t equals 1, so remember that t equals 1, t goes with Smart and Final, x goes with Staters. So r is a rate, so that's all we need to worry about. So r of 1, so that's the rate that people are joining the line, but remember, people were also leaving the line during that time too, and that was at a rate of 12 people per hour, because it was one person per 5 minutes, or 2 people per 10 minutes, and then so 6, so we do have that 60. So that's going minus 12. So r of 1 minus 12 is what we got going on there. And then Staters now, with Staters going on, we'd have x equals 4, and so a little bit different here. And so with that, what we'd want to do is, because this is the number of customers in line, so instead we'd be comparing that with s prime of 4. And so we'd want to know, with that, we want to take a look and compare which one is greater. And so we'd have r of 1, so that's 5.99 1 e to the 2.996 times 1 if you really want to do it, okay, minus 12, which means 107.852. So that's how fast, that'd be people per hour, customers per hour, how fast the line was growing right then. Now stators, as prime of 4, would be we'd be looking at the derivative of this function. So just use the derivative feature, and you're going to be able to use calculators and notes and all that stuff. And as I'm not sure how they plan on maintaining academic integrity in this, but I know that make sure your things don't be stupid, and make sure you're set for radians. So I know Miss Trujillo is very, pretty much set that there's going to be massive amounts of cheating going on. So we'll see how that looks. But this comes out to be 18.75, and so definitely this was larger. So you can see that the Smart and Finals line was growing much, much faster. Probably when I wrote this, I must have screwed something up, but at the same time, I was also trying to do some yard work. So, but anyway, so here's something for you. I guess we're not getting back together, but I will keep posting things to help you guys get ready for May 12th all the way up until then. So hopefully this will be of some benefit. If there are things that I'm like ideas, topics that you want to talk about, let me know, because I really do enjoy this, and yeah, just let me know. All right, I hope this post's fine.